Hello and welcome back to part 4, the last part of the tutorial how to make a custom crisp pixel art font for Unity. If you want to check out the previous parts, check the links in the description. To watch part 3, you can click on the link card in the top right corner of this video. Where do we left off in part 3? We worked in Unity and we created this canvas with a panel and a text object, and in this object we created some writing tests with our newly created pixel art font, and we created also the TextMeshPro font asset to use it. I showed you also the workflow with the capital letter M as an example, how you can extend your pixel art font and make the changes apply to the TextMeshPro font asset. In this part we will now focus completely on your font size and how you can make sure that you scale your pixel art properly so that it is always crisp. To do that, we first need to take a look at our setup again. For the canvas scaler, we are using the reference resolution set to the native resolution of our project, which is 640 by 360. And for the PPU value, we are using a value of 16. So these values are very important. If you have different values here, change them and also change the camera orthographic size according to these values, because otherwise you won't get any crisp results. With the PPU value of 16, we also applied this to all the sprites that we are using in this tutorial. I showed you this one earlier. It holds, for example, this UI sprite, and here are two more. These are screenshots that I show you in a moment. So first, let us take a look at the relationship between the screen resolution and the font size, because you might ask, why can't we just use any font size? Why isn't that possible? To show you this, let us first change the game view to the native resolution. I click the panel again to focus it here in the scene view, and we zoom in. You see here this light gray grid represents this game view resolution. I zoom in here in the game view as well, making sure that it is also set to an integer multiple. And you see currently, since we are using the native size, everything fits in very nicely in the pixel grid. So one font pixel equals to one screen pixel. So there's everything nice. But if you set it to 6, for example, now one font pixel is smaller than a screen pixel, and now the font is not readable anymore. And this would also be the case if we use any size larger than our native size, for example 14. And you see over here now, the problem is that the font pixel is a little bit larger than the screen pixel, and for smaller font sizes it's the other way around. Now the font pixel is a little bit smaller than the screen pixel. So the scaling is really important. We can only use integer multiples of the native size. So that means if we use, for example, 24, you see now one font pixel consists out of screen pixel and everything is crisp. So this is the important relationship here. And to show you the integer multiples of our font and the native resolution of our project, I prepared a small table for that. So here we have on the top table all the integer multiples of our native resolution, and in the bottom table we have the integer multiples of our font size. So this is why I like this native resolution very much, because it scales very easily and very nicely to common resolutions. Times 2 gives us HD, times 3 gives us full HD, times 4 WQHD, all the way up, for example, to 4K, which is times 6. So that means if you scale your game, so with the native resolution to these resolutions over here, you are always fine because you are using an integer multiple of it. If you have a monitor with any other resolution, you would usually for pixel art game use black bars and scale it either to the width or to the height so that it fits there. Or you would change the orthographic size of the camera so that you either see more of the game or less of the game, but in that way you can make sure that it is always crisp. So the same applies of course for the font size. And I show you an example here in Unity. I prepared a screenshot. So this is just a game object with a sprite renderer. Let me enable this. And this is from a game that I'm currently working on. This also uses this native size of 640 by 360, and it is a screenshot of a title menu. And for a title menu, you see over here, I also use a custom pixel art font with a native size of 12. So for the smaller elements, I use the font size of 12, and for all the larger elements, I use double the size. So if you are only using the native size and integer multiples of it, so like I showed you in the table, 12, 24 and so on, then you are completely fine if you scale your game native size properly to the monitor you play on, and if you are using the scale mode, scale with screen size. Then you can make sure that you are always crisp and everything is fine. To use, however, smaller font sizes than the native size of 12, there is a small trick, and I show you this in a minute. So first, we take a look closer at our panel and let us take a look at larger font sizes. So we set the game view, for example, to full HD. I double click the panel again to focus it, and I zoom in here so that we see everything a little bit better. And you see now over here that if I zoom in, you see this light gray grid, which represents the resolution. And since the full HD resolution is 3 times our native resolution and our font size is set to the native size, we have the situation that now one font pixel consists out of 3 screen pixels. And we can use this to our advantage to actually make our font size smaller, but we can only go in steps of 1/3 because of this font pixel to screen pixel relationship. So 1/3 of 12 is 4, that means 12 minus 4, and now we have the font size 8, everything is crisp and nice, and we can go even one step further, so 8 minus 4 again, and you see now over here, for this resolution, full HD, the bottom line for the font size would be 4. Any other font size, for example 5, would end up in some distortions, or for example if we use 10. So this is the important relationship here. So what we're gonna do is we would find out all the suitable font sizes for the game resolutions and pick the one that we want. And to do that, I prepared another table over here. And in this table, you see on the left side the native resolution, the integer multiples of it, and here the scaling factor. In this column over here, we have the monitor to game resolution, because we assume now that if you have a full HD monitor, you would also play the game in full HD. That means you would apply a scale factor of 3. If you have a monitor with another resolution, you would, like I said earlier, either fit it to the width or to the height so that you can make sure everything is scaled to an integer multiple. If we do that, I showed you earlier that we can then use smaller font sizes, but they are dependent of the used monitor resolution. And you see over here, for full HD, we can use the font sizes 8 and 4, and we get them by getting the inverted value of the scaling factor. So the inverted value of 3 would be 1/3. For HD, the inverted value of 2 would be 1/2. Here you can only use the half the size and the native size. For full HD, 4, 8 and 12, which are 1/3, 2/3 and 3/3, which is 1. That means for WQHD, we have a higher scaling factor and we can get even more font sizes that are crisp. And if we use any larger scaling factor, we can get even more font sizes. But also keep in mind that then all your UI elements would be quite large as well. So the thing is now, how can we implement that, since we don't know on which resolution our game will play it on? We use here in Unity another scaling mode. And the scaling mode is called constant pixel size. So we define a fixed pixel size, a fixed scaling factor for all the HUD and UI elements where we want to have smaller font sizes. To do that, let us go back here in the table and let us pick for now, for an example, the full HD resolution. If we take full HD, we have now, so to say, our native resolution and a separate native resolution for all our HUD elements or UI elements where we want to use smaller font sizes. So we have then, so to say, 2 native resolutions for our game. And this enables us to keep our font always crisp and pixel perfect. How can we implement this? So let us go back in Unity and let us make a small prototype for that, because I want to show you the advantages and disadvantages between the scale with screen size scale mode and the constant pixel size scale mode. To do that, let us go in our panel and we first change our text here to use only 1 line, and then we create 2 more text objects that text objects that are using the smaller font sizes. So we have 12, which is the top one. For the middle one, we take 8, and for the smallest one, we take 4. So these were the resolutions related to the full HD resolution. We change the position of these elements. I move them down a bit so that we have them all underneath each other. And important, change also the positioning to integer values so that they are nicely in the grid. Okay, so now we are done with that. And what I'm now gonna do is I copy this canvas and paste it over here, and I change the scale mode to constant pixel. Now you see the property changed. You see now the properties changed, and there's now a field for a fixed scale factor and the PPU value. We leave the PPU value with 16 for now, and for the scale factor, if we go back to our table, we now take this scaling factor of 3, which will then be fixed. So to see the differences, we move this panel on the constant pixel size canvas a little bit to the side, and I want also change the pivot to the bottom right so that the pivots of both panels are at the same position, because to show you the differences, I also created a screenshot. This is a screenshot from in-game of the game that I'm developing. So patient saw, you see here over here, these elements, a small note on them, I use for them a separate font. It has a native size of 8 pixel. I probably will change also to the other 12 pixel font, since I now can use smaller font sizes, but keep this in mind. Currently I only dedicated this for numbers and digits. The point of this screenshot is though that we have some context, and this context means that we want that these panels are now positioned on the small edge of this leaf, because when we use different scaling settings, the position also can change. To do this, we move now the panel on the canvas with constant pixel size a little bit to the left, so that it is also positioned on the smaller leaf edge. And we need also make sure that the position is set to an integer multiples, which it is. So to distinguish the panels better from one another, we change the panel of the canvas with screen size, scale with screen size, to a reddish color. So a little bit to the red. And now we zoom out a bit here in the game view, also making sure it is an integer amount. I make this window a little bit smaller, and we zoom out here in the scene view. And now see what's happening when I change the resolution. So we set it, for example, to HD, and now you see that our left panel in the canvas with the constant pixel size is kept the same size, and the other one was scaled down because HD is smaller than full HD. If we take a look here in the scene view, you see also that the position changed. So the drawback for this constant pixel size scaling mode is that now everything kept the same size, but the position was not scaled accordingly because it kept the same size. So we need to do this manually. I'll show you in a moment how we can do this. But the positive side is that our font is now still crisp, regardless of the different resolution. And if we zoom in here on the other panel, the reddish one, you see over here that the font is distorted, the glyphs are distorted. And if we zoom a little bit further in the scene view, you see the reason why, because everything scaled down, and now the font pixels are not aligned nicely to the screen pixels. If you take a look at the font size 8 in our other panel, you see everything is aligned nicely. So this is the most important positive side of this constant pixel size mode. To scale now the position correctly, let us go back in our table over here and take a look at the bottom table. So for our native HUD resolution full HD, I calculated already all the scaling factors for different resolutions. We are also taking a look at the integer multiples of the native resolution. So that means, since we are currently in HD, we need to take a scale factor of 0.667. How can we get this value? We simply divide the width or the height by the width or the height of the native HUD resolution. Here I use the width values, but also make sure that you are using the same aspect ratio, or you're using the correct resolution that your game is rendered to. So if you have black bars, then make sure that you use the resolution that your game is played in. So here we need to use 0.66 for HD. That means we apply this factor to the position, so to the X and Y value. So 0.667 and to the Y value times 0.667. And now you see the panel moved nicely to its positions where it should be. You see also when here in the scene view that our frame is a little bit thicker than the other frame because it uses this fixed scale factor of 3, so 1 screen pixel more compared to the other frame. If you want the frame to shrink down as well, you can apply this factor of 0.667, so 2/3, to the PPU value as well. So now we have a different value and the frame has the same thickness as the reddish one. But I honestly think that it is better to leave this PPU value fixed, because as you see over here, now the size of the native font size and of this UI element are the same, and I think this is a little bit more consistent. And for all the smaller font sizes, since they are smaller anyway, it doesn't make a difference there. Okay, so if we go now back to our table again, we see here that for each these resolutions we have a different scaling factor that we need to apply to the HUD elements that we want to use. So we can write a simple script for that and apply this factor to all these positions. But there is one thing that I want to point out last. For example, for a resolution of 4K, we have a very nice fit, because if we take the native HUD resolution of Full HD and multiply it by 2, we then get 4K. So that means if I go back to Unity now, what we would do for 4K, we would move our positions back to the default values, which are, if I take it here from the other panel, because the pivots are on the same point, -30 and 18. And then if we change the resolution to 4K, you see here how the positioning is messed up, but we can very nicely adjust this by applying the scale factor to our constant scale factor, so 3 times 2. And now you see everything scaled nicely, and it also scaled nicely for the reddish color panel, because if it used the native resolution of 640 by 360, and if we go back to our table, the native resolution times 6 or the native resolution times 6 fits also very nicely in 4K. The last thing I want to show you is that since our panel has now the constant size, so constant pixel size, keep in mind that for smaller resolutions, if we set our factor back to the original one, to 3, you see over here, if you change it back to our native resolution, that since it keeps the constant pixel size, it is quite large. So make sure that you align it, position it correctly, and think about the font sizes in relationship to the resolution size, and maybe change the setup there if you want to. Okay, to summarize the results, let us take a look in our last table here, the pro and cons. So like I said earlier, we have two possibilities. Either we use the canvas scale with screen size, or we use the canvas constant pixel size. If you only want to use the native size of the font, for example 12, and only integer multiples of it, then I would use the canvas scale with screen size, because you don't need to take care of the UI positioning and the scaling. But you are of course restricted only to these integer multiples, and you can't use any smaller font sizes. If you want to have, on the other hand, for HUD elements or for an item description box in your game, smaller font sizes, then use the constant pixel size canvas scaling mode, but then you need to write a small script to take care of the UI positioning, and you can optional scale the PPU value as well if you want that the frame changes in width as well. So then you can use the native size of the font, the integer multiples of it, and also a set of smaller font sizes, which of course then depend on the native HUD resolution that I showed you here in the second table. So you can choose the values according to this. If you have a different font size, for example 16, then these values would change as well. So keep this in mind. And it also depends on the native size of your game as well. Okay, so with that, thank you very much for watching. It was quite a journey. So we went through the custom pixel art font creation process in Inkscape and FontForge, and I showed you finally how we can create our TextMeshPro font asset and how we scale our font properly. So I hope now that you are set up right to use your custom pixel art font. And with that, thank you very much for watching. If you liked the video, please leave a like and consider subscribing for more tutorials and game development related topics. Don't hesitate to leave a comment if you have questions or want to leave feedback. I really appreciate that and it would help me a lot. Thanks again, all the best to you guys, stay safe, and I see you in the next video. Goodbye!